Hey guys, in this video, we're going to talk about mean and variance, and we're going to work in Excel to do it. So here's our function for the sample mean of a variable x. We call it x bar, or if it was a variable y, we'd call it y bar, etc. Putting a little bar over it in my class means it's an average. And that's equal to 1 over n times this big monster thing with a bunch of xi's on it. Well, let's talk about this notation first of all. This is a sum, S-U-M. Well, actually, it's a Greek sigma, but it means sum. We're going to sum from I equals 1 up to n of all the xi's. And to help illustrate that, I built something over here. I built a little vector, 10 observations of x. And I'm going to help you to see what the i's mean. So x is this whole column. It's everything in there. It's all those x entries. Each observation of a random variable. The first time it was 1, the second time it was 4, the third time it was 7, the fourth time it was 3, and so on. So I'm going to put an index of i's in here. I'm going to say 1, 2, 3, and I could keep typing. I'm feeling lazy, so I'm just going to highlight those. And Excel is going to continue the pattern and just go all the way through 10. Or if I'm feeling really lazy, I can just double click that little box there, bam, and it fills the whole thing. Okay, but that's not why we're here. So what is x? What is x1? It's 1. What is x5? There's I equals 5. So x5 is 9. What is x10? It's 6. These xi's, it's talking about which row, the i's are talking about which row of the variable x. Now, when we sum it, we're summing from I equals 1 to n. N, by the way, is the number of rows. Excel is nice because our rows are labeled. This is row 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 10 rows that are covered. We can also cheat a little bit if you wanted to. So let's introduce our first function. Let's count how many rows are here. I'm going to say, let's just put n, which is our number of rows. I'm going to just do that. That's going to be equal to the count. Now, when you start typing a function that's in Excel, if you know the function, great. If not, you can Google it, or you can just start guessing. I start giving count, and it gives me a whole bunch of options there. And this one says it counts the number of cells in a range that contain numbers. So maybe I'll do that. So I double clicked it, and now I'm going to highlight the range of cells. I'll just highlight a whole bunch of stuff. And then I'll close my parenthesis. And it tells me that there were 10 cells there with data in them. So if you like just eyeballing it and saying from 2 to 11, that's 10, great. Or you can use this count command, and it'll tell you this column had 10 observations in it. So that means we're going to add x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 plus x8 plus x9 plus x10. That's what this sum I equals 1 to n means. We're adding up all n x's, but n is 10 is the number of rows in our data. And then after, we'll divide by n, or 10, to get the average value. So let's add them up. Let's say the sum of x. Okay. Yeah, we'll just do that. I don't know how to type sigmas in Excel. Actually, I probably do. Let's go. Sum of xi's, and that's going to be equal to, now there's 2 ways we can do this. One of them will only work with small amounts of numbers, and one of them is better for the overall. I'll do the bad one first. Please don't do this, but I just want to give you an idea of how Excel works. I can say equals which tells it to start doing a calculation. And I could click on this one, click on the cell I want, and say plus that one, 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 plus that one. Right, they add up to 50. Okay, there's your sum of the xi's. That's a really clunky way to do it though. And I would only ever do that if you only have like 2 or 3 things you're adding. Otherwise, I would just do something simpler. Let's say equals sum. There's that sum command. I'll open up my parentheses and I'll highlight the things I want to add up. Close my parentheses, and it adds up to 50. It's going to be really nice, especially because most data sets have a lot more than 5 or 10 observations. Okay, so let's take just a quick minute to explore what we've done so far. So far, like I just said sum, and then I highlight all the things I want to do. Or count, and I'll highlight all my observations, or whatever. But let's explore a little deeper. This says equals sum B2 colon B11. Well, if you notice along the top of your Excel spreadsheet, there's a bunch of letters. And along the side, there's a bunch of numbers. The whole thing is like a giant game of Battleship, where there are coordinates, a letter, and a number. And so this is saying we're starting the sum at B2. B and 2 is this 1 here. And we're ending at B11, which is this 6 here. And the colon says include everything in between. So this is saying B2 through B11. There's other ways we can mix data. We'll deal with this later. But if I put a comma, for instance, it would just add B2 and B11 separately. B2 through B11 is that whole range. And something kind of nice is Excel is always going to highlight for you the data being used. Look at that again. When it was just B2 and B11, it highlights them separately. When it's the whole range, B2 through B11, it highlights the whole range. So it will show you with shading what you're making it look at, which sometimes is very helpful. Okay. So we got our coordinates. We started working through some functions. Let's get our mean finally. Let's do the mean, which is, you see how that doesn't actually fit. If there's ever anything that doesn't fit in your view, but you want it to, you can drag your cursor to the edge of that column. See how it switches from the arrow to this weird thing? Click and hold and drag it over, and you can make it as big or small as you want. Other option is just double click when the cursor is like that, and it'll make it fit automatically. Let's see. So let's do the sum of the xi's over n equals B2, or 50, divided by 10. Now notice it's D2 over C2. It's not 50 over 10. Okay? It's saying whatever is in this spot, divided by whatever is in this spot. Okay. Quick note about highlighting. If you want to highlight a whole column, you can. Just click on its letter. If you want to highlight a whole row, you can. Just click on its number. If you want to highlight multiple columns, click and hold your click and then just trace it over to however many you want to. If you want to highlight multiple columns that aren't connected, and highlight this one, hold Control, and click on another one I'm interested in. Likewise, I could start stacking columns and rows. I'm not sure why you'd want to do all this, but hey, it's a thing. All right, there's our mean and some basic Excel crap. Let's go to variance. Got an uglier equation, and it'll let us practice our PEMDAS a little bit. Okay, we've got our same 10 observations of X, and we've got a sample variance over here. New equation because it's a new variable. Or sorry, new statistic, not a new variable. Let's see, what is it? At the core of it is the measure of how far things are from the mean. So X bar is the mean. And we're going to be looking at how far each observation, xi, is from the mean. And then we're going to square it. So squaring it's interesting because it means that stuff that's really close to the mean, you're squaring small numbers, and so they're not going to get very big. Stuff that's really far from the mean, you're squaring big numbers, and those get really big really fast. So this is giving extra weight to stuff that's farther away from the mean. And so if our observations are far from the mean, the variance will go up. And if they're close to the mean, and our data is really clustered and centered around there, then the variance goes down. So higher variance just means your data is more spread out. Lower variance means it's more focused in one area. Then what we're going to do is we're going to add up all of these squared distances and divide by n minus 1. We divide by something like n because when we start adding up all these squared distance, it could just get absurdly big if you have a large data set. But adjusting for the sample size keeps it so we can compare the variance for small sets and for large sets. Anyway, how do I want to do this? We could do something like this. I could say equals, no, not equals. I could say x minus x bar. I don't know how to type it with the bar on there, but yeah, it should do. So before we can do the x minus the x bar, let me say xi minus x bar. Before we can do that, we got to get x bar in here. Now I could say this thing is equal to xi, which is the one in the same row, minus, and I could go to the other sheet and click on the mean. That would work. 1 is 4 less than 5. But I want to illustrate this a little bit differently, so I'm going to take this moment to show you that there's actually a faster way to get the mean. I'm going to say this is equal to the average. Yeah. By the way, Excel has like millions of, I don't know how many equations it has, but it has lots of functions built in. And I guarantee you that the average or the mean is one of them. So I type average, drag over all that stuff, close it, and it gets 5. That average function is all of this stuff built into one. So this was me like helping you to practice something that we already know how to do, but we can also outsource our work a little bit and let those programmers who did it all for us do their thing. All right, so xi minus x bar. x1, we can say this is equal to b2, which is our xi for that row. And we can subtract the mean by clicking on our mean, which is b14. Or if I wanted to, I could click on the one in the other sheet, wherever you've got it stored. And hey, look, 1 is 4 less than 5. It's -4 from the mean. Great. So we should be able to just double click this little box and get all of the rest of the calculations are the same, right? Yeah, so 4 is 1 below the mean. Wait, that's just saying it's 4. And 7. Okay, so we need to look because this is a common mistake. And this is one of those moments where it helps to see the colors. So I'm going to click on the box, and then I'm going to click on the equation for the box in the formula bar. Let's see, it's saying B3, which is the right one, it's the xi for that row, and it's subtracting from 1 below the mean. Let's see, go to the next one. B4 from 2 below the mean. So that's what's going on. You see, when we started, we said everything, we said this minus this. And then when we dragged it down by one box, it said, well, now it's this minus that. When we dragged it down again, it's this minus that. It's keeping the ranking of the two things and just dragging them both down. So what we need to do is have a way to to lock our equation on this point instead of having that point adjust for every row. And that's really easy. Dollar signs. If you put a dollar sign, you lock the D. If you put a dollar sign before the number, you lock the number. And so now when I drag it down, each one is going to be locked on the actual mean each time. And so let's see. Yeah, 1 is 4 below 5. 4 is 1 below 5. 7 is 2 above 5. 3 is 2 below 5. All right, so those all look good now. We use those dollar signs, so we can do all these calculations and lock it on the mean. Now let's take these, Control-Z. Now let's do the squared part, because all we've done is this chunk here. We still got to square them and add them up together. I'll say squared. I'm too lazy to type the whole thing. That's going to be equal to the thing to the left. Now, when you want to square something or do any exponent work, this caret symbol, so holding shift and typing the number 6, that caret says exponent. I want to say to the second power. That's squaring. Minus 4 squared is 16, and so on. Okay, we've got our xi minus x bar squareds. So far, so good, I think. You'll notice that when you square negative numbers, they become positive. Variance will always be a positive number. It's a measure of how spread out everything is, positive or negative. Now, we need to add all of these together. So let's see. This is equal to the sum of all the stuff above it. And that is the sum of all of my xi squareds, or xi minus x bar squareds. We're almost done. Okay. Xi was given to us, xi minus x bar we solved for. This column is xi minus x bar squared. And then we've added them, so we've got the summation done with. It's 72. Now we just needed to multiply by 1 over n minus 1. I call this s squared. That's our sample variance, is equal to the sum of all this stuff times 1 divided by n minus 1. Now you can't just type n minus 1 because Excel doesn't know what n is. I could pull it from the other sheet, or I can just redo it. Count of all those, our number of rows is 8. 72 divided by 10 minus 1, so divided by 9, is 8. That's my sample variance. And I ended up not really using that because I retyped it over there. Okay, so just for fun now, you guys, don't forget, variance is also a very common statistic. Let's just check our work. If I type variance, we can use that one, or maybe we just use the plain simple variance. Just var is the old traditional one. Variance of all of my x's, so that's variance of my x variable, is 8. Hey, we solved it and got the same number as the pre-canned one. Common excuse is that by the time students have made all their xi's minus x bars, they often try to do the variance of that instead. They'll do something like this, but that's wrong, because they're taking the variance of this as if it's its own variable. But this is just one of our steps for getting the variance for this variable. So we like it. We're taking the variance of x is equal to that. All right, now, just for fun, I'm going to do a quick, let's just do a rand between I'm just going to generate some random numbers, you guys, from minus 50 to 50. And I'm going to make a boatload of these. Okay, I've got 953 of those randomly drawn numbers. This is a bigger sample. We could do all those calculations again. I just want to show you some tricks for getting all of it at once. If I wanted to get the mean of this, the average, I can just highlight that whole column. And it gives it to me. Now, that might not be true if it's got headings. Let's see if I called this X. No, it does, because the X's don't, sorry, stuff that's written doesn't get calculated in. So I can get my mean that way. Now, if I wanted to do a variance, by the way, you'll notice it changes every time I type anything. That's because every time I do, it's drawing another random number. Don't panic about that. Yeah, whatever. Now, if I want the variance, another approach, if I want to highlight that whole column, I don't have to just click on D, because maybe there's stuff somewhere down there that isn't part of the variable. I don't know. Depending on how you're organized, you might want to deal with this. Let me type variance, and then I'll start with D2, my colon, so I'm going to trace it all the way down. But I can hit Control and the down arrow while I'm on this column, and it will take me to the bottom of that variable. And just automatically tells me it's going from D2 to D954. And it gives me the variance of that. Guys, if this video was helpful to you, great. If it was helpful to you, you're not an XVAL expert yet. We are just getting started, but it's a couple of useful things in here. I know it was long and kind of dry, but good luck. Hope it was useful. Peace out.